I will be talking about hot air balloons and their application to the gas laws regarding pressure, volume, and temperature. So, how do hot air balloons work? Hot air balloons use heated air to fill up the balloon, called the envelope. The burner is the part that actually heats up the air by burning propane. So, if you recall, Charles's law states that as temperature increases, volume increases with it. This means that V1 is directly proportional to T1, and V2 is directly proportional to T2. As we can see here, I've drawn a visual of the hot air balloon example. When the pilot increases the temperature of the air, he or she also increases the volume, which completely fills up the balloon. This causes the balloon to rise because the air inside the envelope is less dense than the air outside the envelope, so it floats. Then it is carried by winds over to its destination, where the pilot allows the balloon to cool, so temperature is decreasing, and since that's happening, volume is also decreasing. And then this allows the balloon to descend and land. So, let's try a practice problem. A balloon takes up 750 liters at 21 degrees Celsius. If it's heated to 95 degrees Celsius, what will its new volume be? So, to start this question, we're going to need to convert Celsius into Kelvin. We do this by simply adding 273 to each of them. So we have 21 degrees Celsius plus 273 equals 294 Kelvin. And we have 95 degrees Celsius plus 273 equals 368 Kelvin. Then we look at Charles's law and we see V1 over T1 equals V2 over T2. And since we want the new volume, we want to isolate V2. That's going to be our answer. And we do that by multiplying each side by T2. So then what our equation is going to look like is V1 times T2 over T1 equals V2. And then all you gotta do is plug in the values. So V1, 750 liters, times T2, 368 Kelvin, all over T1, 294 Kelvin, equals V2. And our Kelvin units cancel each other out, and we're left with liters, which is fantastic because we're looking for volume. And so what it actually multiplies to is 938.7755 liters. But since we're in chemistry, we got to use the proper amount of sig figs. So this just rounds to 939 liters. And that is our answer to this problem. Alright, so once again, hot air balloons exemplify Charles's law because, as we can see, when the pilot increases temperature, the volume increases as well, which makes the air less dense, and allows the balloon to rise. And then when the pilot wants to descend, they allow the balloon to cool, which cools the air, decreases the temperature, which decreases the volume, and that allows the balloon to sink. And that's the conclusion of this video.